Hey, welcome back. Good to see you again. Thanks for joining the channel. Hope you're all well. So today on the bench, Sansui 9090. This thing's massive. It is a beast, and wow, I don't know what to say about this. It was quite a backbreaker putting it up on the bench too. So I'm gonna have my fun with this one. It's gonna be interesting. So I just did a 771 Sansui, and that was interesting. I enjoyed doing that. This is going to be like scaled up, and yeah, it's got a nice, well, actually I'm not going to say it's that nice. It's actually kind of beat up. The wooden case is kind of got abrasions on top, some scratches, got a burn here, and some of the some of the veneer is actually broken off on the bottom corners. So it is actually, and then it looks like the case is separated here on this corner, and this corner looks intact. So I don't know how that comes out of the case or what, but we're gonna have to do something with that, I think. It needs a good clean. The knobs are filthy. Yeah, it's quite dirty, and I don't think it's ever seen a good cleaning. It's got some scratches around the phono, the headphone, and everything. Yeah, it's quite dirty and dusty, but it's all good. We're gonna get it working. So I have speakers connected. Let's see if this thing actually does anything. Turn the power on. Let's plug it in too with help. Let's turn it on, plug it in. All right, can you see that? Let's turn this thing on. Jumped up to about 130 watts, and then click, I heard a click, and it's settling around 50 watts. I don't have any lamps though. It's coming down, 35. What is going on here? I have, let's see. And a noisy left channel. That's left channel. That's quite noisy. Considering, or hang on, I'm on FM. Yeah. Noisy, still on left channel. Tape monitor switch. Let's go to FM. Meter selector, muting, off. We still don't have anything on the... So it's drawing 36 watts. Let's see if we can get any music out of this thing. I'm on FM auto. Stereo, muting's off. Well, there we go. Bad switches. That's the 4-channel adapter switch. So that takes the FM signal, feeds it out the back through this switch, and then brings it out. Or bypasses. That's... Meters are lit. Tuning capacitor is dirty. Tuner is not working very good at all. Signal meters. Yeah, this incredible colors of the leaves. Tuner definitely needs an alignment. This center tuning dial meter is way off to one side, and we're not getting very strong signals here. So the good thing is both power amplifiers are working. Tuner is working. Let's go to AM. Cool idea. Would love to. Oh, we had a little light here. So we got a dirty switch or something. This thing's rough shape.
Textiles that are ready to walk around in the garments.
All right. I have a good idea what we need to do here. Let me see about our controls.
The evidence we've got says you could drastically reduce that, but it would make garments last longer, which is also more sustainable. It's going to be the same with the particles from the tire wear. When you drive around, put your brakes on and go around a corner.
Noisy.
Your tires are wearing out, of course. We know you need to renew them. Well, that's generating billions of tiny particles which are washed from the road surface, ending up in the environment. So it's about action on the large items that become microplastics.
Everything seems okay, it's just really dirty.
Textiles, and it's about action to prohibit.
Okay, I have a good idea what's going on here. Now, filters, audio muting. Yeah, we just got dirty switches, dirty controls. So that's all going to need fixing, reworking, cleaning, and we have to get our lamps. I think our lamps are working. They are just not being switched on, or something is... I did see lamps coming on, so that part is working. Let's get the cover off this thing and see what we can figure out. Yeah, this is one of those receivers where I can't get my camera back far enough to get it all in frame, so this is what you get. So 4 screws out the sides and the lid comes off. Looks fairly good underneath. I don't see any heat damage or scorching. Looks pretty good. This all up top here is all tuner. Got tuner front end, dial scale, lamps, everything. And apparently this can come out as a module. You take this whole thing out. You just have to disconnect some wires. And that's probably what I'm going to end up doing in this on this receiver. Ooh boy, you got some big iron back here. This thing, this is why it weighs so much. It's got a massive transformer. It's like the size of a small watermelon. And here's our audio driver board. Everything looks pretty good. I don't know, it looks untouched. Let's see if we can swing this around so you can have a better look. Get rid of the antenna. It looks a lot like the 771 that I just did. It has an upright board here for the driver sitting on a power supply board. Down here we got a phono section with 2 ICs, so we got a couple of chips doing the phono amplification, equalization. And then here's all our switching. We have, this is our function switch and this is our tape monitor switch. So those 2 switches will definitely need to be cleaned. Got our tuner front end with a variable cap in there that's noisy. We have to take that apart and clean that. Look at the size of this transformer. Just wow. Quite dirty. I'll take it outside and give it the compressed air treatment. I just want to I'll take this cover off first, and so I can get the compressed air going. And I'll also remove the bottom plate, and then I'll take it outside and get it cleaned. This is kind of odd. Get this out of the way. Get this cover here. Oh, I guess it's just to keep the dust out. I guess they figured that wasn't good enough, so they devised this little thing to put over to block maybe fingers going in there. I don't know. Anyways, there's our heat sinks. And it looks like we all have original silicon in there. 2SC. I can't read it. But they're all 2SC, so that's quasi-complementary. Interesting. And I think if I remove these screws, this outer heatsink thing comes off, and then that exposes the transistors underneath. Okay, so there is a wood trim piece that goes along the bottom. It's just a finishing trim that comes out, and the bottom panel comes out. It's quite dusty. Nobody's been in here before. It's all undisturbed dust. And then we have the innards. We got our big power transformer here, the power board. This is our input board, switching, tape monitor switch, function switch, right here and here. A couple of 6800 microfarad 71 volt caps, tone board. This is our volume control, loudness, and stereo mono switch on this board. Tone controls, and this is our speaker switching, relays, protect circuit on this board. It looks like there's one relay here for sure. And then up inside there you can see the tuner board, the bottom of the tuner board. Very easy to service. Have all our power transistors connecting under here. I'm kind of excited to do this one because I remember the 771 after I finished it. I listened to that for a while and I really enjoyed that. That's a great sounding receiver. Considering its age and its design, everything needs cleaning. So I'll get this prepped for cleaning and we'll start working on caps. It's going to get the full meal deal. It's going to get all new caps. Looks like I might be doing lamps as well. Set screw on that one. And a lot of work on the switches. So, looks like I got my work cut out for me for this one. Trying to take off the front faceplate, but there's a sneaky screw here. Look at this. Right above the selector switch, there's a screw. I don't know why they did that. There, that's better. Yeah, look at it. Have a look at this. You can see how dirty it is. It's got quite a bit of... This will all clean up really nice. It looked like $1 million when it's done. Alright, just for ease of servicing, I think I'm going to remove the tuner assembly and just give this a try. So we disconnected a yellow wire here. I got this red and black wire disconnected. Now, we have connectors down here. Let me reposition the camera. Hopefully you can see this. There's 4 connectors here, and they are 5-pin, 4-pin, a 4-pin, and a 3-pin. These are all gold plated. That's very nice on Sansui. Put gold plated connectors. So we have one wire here. This white wire that's... I might have to desolder this white wire. That's the only one. And that disconnects everything else from the tuner. So let me get my iron warmed up. We'll get that wire disconnected. Okay, that one's done. So that's all those. And then we have our FM input, antenna input. It's also on gold plated connectors. Very nice for Sansui to do that. So that should be all the wiring up top. I don't know what's down below. Let's remove a few screws and see what comes of this. Let's remove these 2 on this side. Okay, got 2 on the other side. Oh, we got two along the back here. One. And this one. Alright, I don't know if you can see this. There's one connector hidden underneath, right here. Pull this one out. It's a 6-pin connector. And that liberates the harness from the bottom. Okay. Alright, there's also two screws here in the front. One on this side of the dial scale. And then one on the other side. And that should free everything up, so it can lift out as a unit. And we're completely free. And we can put this aside, we'll service this after. Now that's nice because we've got full access here to all the boards. Look at this. Very nice. And we don't have to risk damaging the dial scale or the pointer. That's out of the way, and now we can focus on what's left here. So probably going to start, what I want to do is I should talk a bit about which way I want to take this. It's very dirty, so I want to do a lot of cleaning. So things like these boards here, this driver board, I want to put it in the ultrasonic and clean it. It is quite dirty. This board's quite dirty, so I'll clean these in the ultrasonic. This board, I don't know, I'll probably end up leaving it and just clean it in place. There's some stuff going on down under here. It's mostly going to be cap changing and probably some transistors going in too. Looks like I got some of my naughty transistors. So I'll start working on probably the power supply and see where that takes us. Okay, I got it broken down to what I wanted. I removed the power amplifier and the power supply board, power amplifier. I removed the tuner, and now I got full access to everything. I wanted to remove this because it's quite dirty and it needs a swim in the ultrasonic cleaner. So I'm going to get this cleaned up and put back together. Yeah, it's a lot of dirty stuff going on. I think there's a liquid spill here. There's some kind of staining on the chassis. I don't know what it's from, but it's happened a long time ago and it's dirty. Yeah, what else was I going to say? I think that's it for now. Just have to get cracking. These caps. Oh, these caps, I tested them. These are 6800 microfarad at 71 volts. They both test out at about 7300 microfarad. And they both have an ESR of 17 milliohms. So these caps are really good shape right now. I'm just going to leave them alone, clean them up, and we're going to reuse these caps. So that's a good thing. Everything, all the other caps will get replaced. Everything, even all the ones in the tone board. All the orange ones, the blue ones, the gray ones, the black ones. Yep. Even if they're good or bad, they're going to come out. And we're going to remove this relay, service that, and this board will get serviced as well. So, lots to do. Check out those M6 bolts holding this transformer down. This thing's like a engine block. Okay, I'm pretty much finished with all my cap replacing. Now, this receiver, all these caps here, I haven't found a bum cap yet. They're all good. This receiver has extremely low hours, no burn marks or scorch marks or baked capacitors or baked transistors. Everything is pristine in this. It's like a time capsule, to tell you the truth. There was nothing wrong with any of these caps that I replaced. They were all still functioning fine, even though they were 50 years old. I did do some changes. I got rid of these two fuses on the driver board, and I replaced them with smaller leaded fuses. It gives a tidier look. I replaced the long tail pair, replaced the caps, resoldered everything. Looks suspect, and this is ready to go back in. These are the transistors. They all test fine. These are HFE. I'm going to group them together so that they can be put back in service. And it's all been cleaned. I can put this all back together now. No issues found so far with this receiver whatsoever. Probably the main culprit was the relay. That's usually typically what's going on with these old receivers, is the relay. They stop connecting. So I'm going to start putting things back together, put the transistors in, and the rest of the chassis is all worked over, except for the tuner. I haven't done the tuner yet. Okay, a couple of mistakes I found in the schematic and the service manual. This is board F2546. This is the power supply board. Now, they have a 1 amp fuse here. This supplies a low current, high voltage, probably for phono stage and whatnot. They have here C1. It says 1000 microfarad at 6.3 volts. That's incorrect. It's actually 63 volt cap, because this voltage coming off here is over 50 volts. Here's 52 volts, here's 36 volts after the dropping. So this voltage here is more than 50 volts, so this has to be a 63 volt cap. That's one mistake. The next mistake is, let's see here. Here on these 4 caps, these are bypass caps for the power amplifier, and they are on the power supply board. So as soon as you have a fuse, you have a cap, and then it leaves the board, and it goes to the driver card. But here we got plus 61 volts, negative 61 volts. Okay, the capacitors, these two are orientated properly. These two capacitors are showing backwards. So if you put these caps in this way, you'll blow them up or pop a fuse. These caps should be reversed. And funny enough, they don't have any cap number. There's no C number associated with these 4 caps. Another note, it says 2.2 on the schematic. In reality, it's 4.7, and so that's a little difference there. Okay, working my way through the tuner. I have replaced all of the electrolytics with either electrolytics or film. Now I'm looking at this board and I'm seeing a lot of carbon comp resistors. As soon as I see carbon comp resistors, I pull out the ohm meter, and guess what I found? I found a bunch of them that are out of tolerance. So let's see here if I can show you an example of one. This one here I think is 100K. Brown, black, yellow. 100K. And we're right at the tolerance. So we're 5% out. So I'm going to change some of these that are bad. I have another one here. Where is it? I haven't even finished checking, and a bunch popped up already. There was a 68K right here, I think. That one's 5% out as well. 2.2K. See, I don't know if that's correct or not because it's in circuit. What I've done before is I've gone through and lifted the leg of one of the resistors. One leg of the resistors you lift, and then you can get an accurate measurement. It's a lot of work though. So I'm going to go through and see if I can find any more. I'm going to replace those that are out of tolerance. Now if you're wondering, oh, that's not a big deal, that does make a difference. Yeah, it does make a difference because I've gone through a tuner before, a Sony STR230. I think if you want to go back and see the video, I went in through the tuner section, and all those resistors that were carbon composite were out of tolerance, some up to 25% out. And the tuner didn't work right until I got those resistors replaced. So it does make a difference. You want to have your components in tolerance. That's your electrolytics, your other capacitors, and your resistors. I thought the lamps were burned out, but then I applied power I got 7.7 volts applied to this lamp, and they're all wired in parallel. Draws over 2 amps to light this all up. It's almost 16 watts of power just in lighting, but it's all working, so I'm just going to leave it alone. I don't think this receiver's seen a lot of hours. There's no burned out lamps. I still have to check the inputs, the input lamps, and the FM stereo lamp. But I think we're doing pretty good here, and I'm just about done. This tuner, I replaced three resistors that were out of tolerance, all the caps, and I think I have one transistor that needs to go. I think I'm going to go in there and change that one too. It's a 2SC1312 or something. Yeah, I'll look at that and then put this back together. We're just about done. Okay, we're back together enough that I can do a power up, do our first power up, and I want to measure voltage across these lamps. I got 4 lamps here. I think one of them is burned out. I want to replace all 4 of these with LEDs before I put the tuner back in. So let's get this, see here. Can you see that? Hope you can. Here we go. Smoke or fire. Up to 26 watts. Not getting any relay click. No relay click. Is that because... Let's try this again. Okay, what's going on here with no relay click? Let's see if we have any voltages on the output. I think right here, 120 millivolts. Ooh, 65 volts there. What is going on? I'm going to do some investigating here. I don't think there's anything wrong with the transistors. Yeah, let me figure this one out. Okay, I found the fault. Now, it is not anything to do with the power amplifier. It's quasi-complementary. It's supposed to have that 65 volts on the top of the tree. Now, what I did here is I screwed up. I didn't connect this red wire that is hidden under here. I didn't see it. It's not connected. So I have to discharge these caps and then connect that wire. This wire feeds power to this board, which is the speaker protect. So this isn't getting any power because that wire is disconnected. That's my fault. All right, here you can see the wire I missed. Hidden pretty good, so no surprise I missed that. But we'll get it connected. It goes right here. So let me get my iron and tack that wire back. See if I can do this. Alright. A little bit burnt up, but that's okay. Okay. Alright, I remove my resistors from the caps, and we can do another power up. Okay, take 2. Here we go. Power up. Here's our relay click. And here's our lamps. We got 1 lamp out. I want to measure what we have feeding these lamps. I have a feeling it's 8 volts AC. Let's see if I can figure out. It's a black and white wire here. What do I got? We got 6.7 volts AC. 6.7. And where does this come from? This black and white wire. comes from the other side. Black and white. Black and white. So this here, this wire here, is our 6.8 volts. That's AC. Comes from this fuse. 6.8. Okay, that comes from the transformer. So it goes through a fuse and then it goes to this here. And then this red wire goes up here to the switch. Goes up to the switch. There's no DC component on this, is there? No, it's all AC. There's a bridge rectifier right here. AC, AC. So this here is DC. Well, that's 55 volts. We could use a 55 volt supply, but we'd have to drop it down quite a bit with a resistor. And then there's a regulator here. This regulator, 55 volts there. Drops it to 39.4. And that's right here. This is our output, 39.4. We could use this because it's already rectified, filtered, and regulated. So that'll be our drop point for our LEDs, 40 volts, right there. You didn't see that, did you? Let's show you again. Maybe you can see this. Right here we got 55 volts. This is the filter cap, goes into this transistor. Here's the emitter, 39.4, goes around. This is our output right here. So we can tap off this brown wire our supply for our LEDs. So here it is. I got the power meters relamped with LEDs, and you turn it on. And it's not overly bright. It's actually just perfect. And I'll show you what I did here. Let's have a look. So I was able to reuse these two boards. There's a little PCB board that's tacked onto the back of each meter. It had two incandescent lamps, a 10 ohm dropping resistor, and those two lamps were wired in parallel. So I replaced the lamps with LEDs, and the leads on the LEDs are just long enough to reach from the board to the housing of the meter. And you can see the light bleeding through from the back. Two LEDs in parallel. I switched the 10 ohm resistor for a 4.7K, and this wire no longer is fed with 6.7 volts AC. I've tacked this line onto the plus 40 volt supply, so it's been fed with 40 volts, and these resistors dissipate about a quarter watt each, so they do get a little warm. I can touch it, I can feel it with my, yeah, it's a little warm. So I might have to space those up a little higher away from the meter so they can radiate. And then, yeah, it's should be good to go. So the tuner has been recapped, and replaced quite a few resistors on this tuner as well. These carbon comps were out of tolerance. Now I checked all these lamps on all these indicators, all this backlighting. It's all working, so I'm just going to leave it alone. Ready to put this back together, and it's just a matter of dropping this in place and screwing it down. And then we can get on to testing. Okay, we're getting ready to set up for a test, but first we need to do our setup and alignment. for our DC balance and our bias. So we have, let's turn on the unit. You should have click, there's our click. And let's find a ground point. What do we got here? (132 millivolts), is that correct? 130, and the other side 29. Okay, 65 volts there. 65 volts. Okay, so this here is our, let me try adjusting this. 130 millivolts. Let's see if this adjusts. Oh, it does. Turn it down to 0. Okay, what do we got here? 69 millivolts. Let's zero this. If I can keep the probe on. Okay, right about there. We're down to about 5 or 6 millivolts. Spec is plus or minus 10 millivolts. See if we can get it closer. There we go. That's better. Let's try this one. This one's about 40 millivolts. Let's turn this one down. This one's really touchy. Let's try that a little bit of that. Keep turning it down. Okay, we're going up now. Let's turn the other way. So I don't like digital meters. They're really difficult to read. Let's try this. $60, $25. You have to move it and then let it settle. And then we're getting very close now. 3. Plus 3, minus 3. I'm going to leave it at that. I think that's good. See, let me feed a signal in and see if we're getting our working power amplifier. Okay, so my goof up, this is not speaker switch as I thought it was. This here is a speaker switch. So let's turn this off. And then turn it up to A. That's where I got my speakers connected. Not getting anything through here yet. It's just a matter of getting the correct switch connection. Okay, problem was the switch was pushed in. That's my 4-channel adapter. And that will block any noise or signal from getting through the receiver. So now we're back online. We should have a signal. It's very weak. There it is. Okay, now we need to set up the bias, and in the service manual it specifies that remove fuse 7 or 8 depending on which channel we do, and we insert a digital ammeter in series with the fuse that's out, or with this fuse socket, and we measure the current that's going through to the power board, to the amplifier board, and it should be 50 millivolts, 50 milliamps, sorry, for each fuse. Now I've done this on the 771, and I connect up my probes, and then I lift the fuse out of place to open the circuit and let the current flow through the meter. But one of my smart viewers suggested I just get an old fuse that's blown, and I solder 2 wires to it, and then I can use this as a test jig. Just pop it in, and then the wires come out, and I can connect my ammeter to it. So I'm going to do that. I'm going to get this prepped up, get a couple leads soldered to it, and then we'll set up the bias adjustment for the amplifier. So here's the fuse adapter jig I made. Blown fuse with 2 wires soldered to it, and I got the ends tinned. I'll get this installed, and then we'll do our tests. Okay, so connect this up. You gotta watch your flying leads because they contain power, and you don't want them shorting the ground. So I got my meter hooked up. Let's turn off speakers. Let's turn down the volume. You don't want any signal on this. Let's turn it on. And we're adjusting for 50 milliamps. So they said let it warm up for 3 minutes. So I'll let it warm up for 3 minutes, and then I'll bring you back and we'll do the adjustment. Okay, it's been on for 3 minutes, and I haven't touched it, and the current is climbing slowly up to 50 milliamps. I'm just going to let it sit for a while, and if it shoots past 50, I'll turn it down a bit, and if it stabilizes at 50, I'll just leave it alone. So it's at 50 now. And then we'll switch over to the other channel. We'll check that one as well. Okay, the other channel is low, so I'll just turn it up a little bit. And we can then move on to testing. Okay, here we go. That should be good. I'll leave it at that. Okay, now we got the bias and the DC balance adjusted. Let's do a power test and see what's going on with this thing. If it's working properly or not. Get my watt meter out here in the open. There's really no room on this bench for these big receivers. If you can see that. No, you can't. Put it like that, maybe. Maybe you can see it there. Alright. So, our speakers are off right now. Let's turn this thing on. And let's set it on speaker A. There's our tone. Sounds like we got a distortion on the left. I don't know. Let's turn this to speaker B, where our load and scope is connected. Okay, that looks terrible. That's the right channel though. What is going on with this thing? Alright, something weird is happening. Let's check our controls. Might have been just a dirty pot, maybe? Okay, volume. Alright, so let's take it up. Oh, I'm sitting at 21 volts already. We're consuming 338 watts, so we're really up there with the power. Let's turn this to clipping. Okay, let's turn this up to clipping. There's clipping there. Bring it down a bit. Right there, I'm going to say. And we have 33.78 volts RMS on the output. 495 watts going in. Let's just let this go for a while. All this stuff's going to start melting here right away on the heat sink. Things are warming up. Oh, I didn't get my timer going. Here's our timer. Just lay this right here. And we're already at 45 degrees on the heatsink. Okay, I'm going to end the test here. We are at, well, we're at 60, we're almost at 70 degrees Celsius for the heatsink. It's getting quite warm. Yeah, 70 degrees. I don't want to push it too far because there is a thermal cutout on this heatsink, and if I trip it, I don't think it's resettable. It's probably a thermal fuse that I would have to purchase and replace. So I'm not going to do that. I'm not going to go crazy with it. So I did, you know, for about 6-7 minutes, full power. It's pretty good. I think it's set to go. And I think we still might have some dirty controls here. But if we look at the screen, we can work these. A little bit of scratchiness on the base pot, mid-range pot. The treble pot has a little bit of scratchiness. I think we're okay. Filtering. That's a muting, I believe. Yeah. Okay. So, test successful. Let's have a look at some square waves quickly. Let's turn this up. And let's increase frequency. What are we at here? About 10 volts RMS on the output, so we're not pushing it very hard at all. So let's look at frequency. That's 1 kilohertz. Let's go up. 2, 3 kilohertz. Four, 5, 6. I'm starting to see the limitations of the old transistors. 7, 8, 9, 10. We're pretty much losing our square wave. 11, 12, 13, 14, 15. Probably right about there. It's no longer a square wave. Not bad. Respectable. Not bad. Okay, just going through this, and we still have problems. We have no lighting for the tuners. It did flash on when I first turned it on, but now it's out. I think it's a switch problem, because I'm also getting very weak. I don't know if you can see the phono is lighting up just barely. I go to auxiliary, it works. And phono, see if I manipulate the switch, it comes on. But we're not getting anything with the backlighting here. It's completely out. Okay, problem number 2. We're not getting any stereo. It's all in mono. And I can't hear any stereo separation. I don't see any light.
Text 9179. Have you watched it?
Now I have an antenna connected, a good antenna, a strong signal, and I don't think I'm getting full meter reading here. I can't even really see the meters. But we need to fix up this business with the switches. Now I think it's right here. Something is wrong with that switch. Phono? Phono sounds normal. But like again, we don't get. Something is really bad connection with the lamps. And it's no wonder too, because when I had these lamps lit up, it was drawing over 2 amps of current to just light up the front. So yeah, that switch, maybe the switch died, so let's get into this. Okay, here's the circuit for the lamp lighting. It's between pin 41 and pin 39. The switch 01C, this controls the individual indicators for phono, auxiliary, FM, AM, all that. So that's what that switch is here. S01D switches the dial lamps on and off for AM, FM, and FM Dolby. Now this switch is gone, and I think this switch is buggered too. We got power through this line because the auxiliary line, the auxiliary line at pin 42 is on. This one's getting power. What's buggered is the rest of these, and we need to figure out why. Okay, I'm just trying to troubleshoot why we have no dial lamps on the receiver, and I think it's because, okay, let me go back here. This red wire here, this is the power feed from the AC. I think it's 6.3 volts or 7 volts AC that comes in, and this goes to the switch. Now this switch here does the panel lamp. I think these brown wires here are the wires going out to the dial lamps, okay? Because I measure voltage on this red wire, nothing on the browns. But I'm looking at the switch here. If you can see this, I'm gonna go zoom inside. This might flood the camera. You might not be able to see it. I'm gonna zoom in. Get a pointer. So if you can see, this contact here is lifted from the wafer. See, if I push it, it's lost all its spring and it's backed off from the wafer. So I think this is our contact. This is the common on the switch. I think this is our problem, and I think this is caused from overheating. This contact looked like it's all burnt. It probably got overheated, lost all its spring tension, and it's the other ones looked okay. I retensioned this one here, but I'm going to remove this switch and see what I can do for it. I don't know if I can repair this. This spring contact is shot. I don't know if I can transplant one from another switch, or if we can continue using it. It's carrying almost 2 amps of current to the lamps, so that's a hell of a load. And if you have any contact resistance here, it's going to start overheating. That's what happened here, I'm assuming. So let me get the switch out. I got to desolder all this and remove the nut, and then it should come out easy enough. So give me a moment. Alrighty, got the switch out. Wasn't that difficult. Had to desolder all these pins and disconnect 3 wires on top, remove the nut, and you're able to finagle this out of the board. Comes out pretty easy. So what I'm going to do is, this is our problem area down under here. I can see it. It looks burnt, a little burnt. It's a little bit roasted with the heat. I'm going to remove this wafer and see what we can do for it. But first we need to remove the front. Now you gotta remember, whenever you disassemble one of these wafer switches, you have to remember the sequence these wafers are in and the orientation. So if you look at this one, this one's facing down with the pins, and the copper foil traces are this way. This one's facing up with the pins, and the copper traces are this way, and the last one is the same as the front one, so down and facing forward. So they all go in the same way, and you can't mix these three up. They're not identical. They're going to be different, and you can't mix up the orientation of the keying of the shaft. There's two ways this shaft can go in, and you don't want to mess that up. Which you don't want to have this clocked the wrong way, and that would really screw up your day. So let's get, first of all, let's remove these ball bearings because they're kind of in the way. Let's just remove them. This is, ball bearing fell out. Take the other one. Just push the spring down and back it out. Maybe this side. You also got to be careful, don't bend these pins. So let's just, this one's a little more difficult. We'll get it, don't worry. There we go. Got it started. There. Now we got a different spring here? No, it's the same thing. All right. Here's our switch without the ball bearings. So what I'll do is I'll disassemble all this and clean it anyway. But first I want to clock the switch. Which way do I want to clock it? Fully counterclockwise, okay? Remove this faceplate. All right. Now you notice this has a stop in it, so you can only go so far, and it has to go back the same way. I should have remembered which side was top. It doesn't really matter. We'll figure it out, and then we can push the shaft back. You can start to see the damage here. Let me try turning this. Gotta remember there's no stop. So this, the problem with this switch is this leaf here is not contacting the wafer. You see it's got a little bit of a bounce there. It's got a gap. So this switch is dead, and I don't think there's any reviving it. It's supposed to connect on this track here, and it looks all burnt. Let me clean it. Let's use 401B. This is 401B. Cleaning is not going to make this switch come back, because this contact is lost. Quite dirty. I think somebody sprayed some kind of grease. You can see it here. There's residue. Some kind of grease on the shaft as well. That's part of the problem why the switch died. This 401B works pretty good for removing oxidation on switches. You see here I'm just rubbing it and it's taking off the black film. Okay, Counterclockwise. Okay, we got how many positions here? So we got a 5-position switch. This is our contact between for the lamps. This pin here and this pin here, and this wafer here is making contact. So when I turn, this is fully counterclockwise. I'll see. So this is in phono mode right now, and there's no contact between these two. Okay, and then when I turn it one click to there, we're in AM mode, and then it's supposed to make contact between these two. AM, FM, FM auto, and then auxiliary. And the switch is broken. Right? So on those 3 connections, those 3 positions, that switch should be closed, but it's not. Let's check with an ohm meter. Use a continuity tester here. Let's go between this one and this one. Let's turn this. I need 3 hands. He's barely, it's not contacting. Her little beep, and that was it. So what do we do? That's phono right there. So what do we do with this? Well, I have an idea. If you look up here on this switch, we have 1, 2, 3, 4, 5, 6 contacts here that are not being used. And if I look on the switch itself, these carry through up to these rivets. If I look at these rivets on this side, you can see there's contacts there, and there is a way for it to connect. You see what I'm thinking? We can bypass these contacts and use these ones. But we have to make sure that they will still work for us in all 3 positions. So what I need to do is remove this center wafer and have an exam on it and see if we can figure out if it will work or not. We only need to use 3 of these contacts, not all 6. And I'm assuming one of these other ones are common. So what I propose to do is abandon these contacts, don't use them. Switch our focus on these contacts and see if we can get continuity on some of these contacts. I have a feeling these 3 positions here are a switch for the power for the tuner, and I think that's what this is right here. We have either power coming in on this one or one of these. I haven't checked yet. I think there's 12 volts here. If that's the case, we can use a 12-volt relay, and we can have 3 of these pins trigger the relay to turn on, and then the relay can handle the extra current of the lamps, the 2 amps. So that's my proposition here. So let's see if we can do this. Okay, I hope you can see this. So this is our problem right here, switch 01D. This one's is I think it's like 7 volts AC, and that's on this one. Pin 41 comes in. This switch here turns on phono, AM, FM, FM auto, auxiliary. This is what switches on these lamps. And this isn't working as well, so we might have to look deeper into this. But this switch here, switch 01D, it's off on phono and auxiliary, and it's on AM, FM, FM auto. So when it's in one of these three positions, current flows through to the lamps. Correct? Now, what we can do is this here is 12.6 volts. This is power going in for the tuners. And I don't know what this switch does, but this switch here powers the tuners. Okay, so when it's in position 1, let me get down over here, I can read this. So it's position 1, it's in phono. Position 2 and 3 is FM, and position 4 is AM. Okay. So position 2 and 3 are FM. This power goes for FM. FM tuner. Oh, you can't even see it. Sorry. Ball bearings everywhere. And this one here goes to AM. Pretty simple, right? So how do we get this? I propose we get a relay. Get a relay here, and we'll have some contacts on it. And we can wire the contacts across this here. So when the relay engages, it'll make a connection and these lamps will go on. And then all we need to do is ground one side of our lamp, our relay. The other side of the relay we connect here through a diode. Okay, and then this one here we connect through here with a diode. The reason we're using diodes is if I switch it to AM, I don't want it back feeding power into the FM tuner. And if I turn it to FM tuner, I don't want it back feeding power into the AM tuner. That's why we have the diodes. Now we'll have to put a diode here that's backward facing to kill any back EMF that the relay coil will generate when this breaks connection. So when we switch it to AM, FM, FM, this relay clicks on, these lamps come on. And then there's no 2 amps of current going through the switch, it's actually 2 amps of current going through the relay. And this should last indefinitely, as long as the relay contacts don't burn out. And I'll get ready on rewiring this. I don't think I need to do anything to the switch. I can do all this from the back of the PCB board. I can pick off these wires, tack a relay somewhere, make the connections, and we should be good. This I'm going to continue cleaning. I'm going to disassemble and clean all the contacts because it's definitely oxidized, and we'll clean all these contacts and we'll try and figure out why this isn't working. I'm finding a lot of these contacts are bent and deformed, and that's why they're not making contact. I wonder if somebody took a straw from a spray bottle or a spray can and stuffed it in there and bent these contacts. They're super fragile. And I had to retension this one because it wasn't even making contact with the wafer. But it seems to be working now. I go around, it seems to grab it. Okay. You can tell if it's making contact or not is when you go through an open spot, past it with an open spot, the finger should drop and then it comes back up again when you get back onto the metal. And this side here is moving. This one's moving. And this one's moving, so that's all good. We'll put this back together and we'll leave it alone. I think that's the original position. This side here is a basket case. You can't really do anything for it. This contact is up in the air. See how it moves when I touch it? It moves down. You'll never get that to bend down and make contact again. It's been overheated. It's probably lost its spring. these other ones, see, even this one's lost its spring and it's not making contact. So I just take a little screwdriver and just give it a nudge down, just to bend it down just a touch. And then when you see, now I can see it coming up when the metal goes under it. If you can see that on the camera, I don't know if you can. Same goes for all of these ones under here. I can see this one didn't make any contact, so I'm going to push this one down a bit. And then we'll test it. It's making contact now. Yeah, all of these are loose. I wonder how they got damaged. Typically these won't lose their spring just from sitting. That one's good. That one's good. That one's good. That one's good. Okay. Then you follow it up with a touch of deoxit. 100. Just give it a very tiny splash of that and work it in. Hopefully that'll restore some of the function. And position it back to where I started. This looks good. This has been treated with deoxit and cleaned. And then we can put this back in. Put this back in. And close up these tabs. Should have our alignment still. Yep. Close these tabs. Keep the wafer trapped. And then I'll remove this last one. And I'll give it an inspection and clean. Oh, I got a shaft in it, that's why. That's why it won't come out. Yeah, that's pretty dirty. Somebody sprayed something on here, it's like grease or something. You can see it here, the stain. Some kind of can, grease in a can. Okay, I'll get busy on this. Alright, boys and girls, mounted the relay up here on this board. And I ran wires underneath to where they need to go. You can see here it's kind of a mess. I got a ground connection. I have supply voltage for the relay here. No, actually this and this is the contacts for the lamps to turn the lamps on. If I short this out, it turns the lamps on. I got a ground connection. Where's my B plus? And I picked off the voltage for AM and FM right here off of terminals 52 and 48, I believe they are. I ran my two diodes, runs to the relay, so everything's working. So right now it is not turned on. Let's turn this thing on. Turn it on. Now, let me shut the lights off here. We got no lamps except for our meters, right? Because I am in phono right now. If I turn it to AM, our lamps come alive. You hear relay click. FM, AM, auxiliary, okay? It's all working now. Now I do have a problem with the phono lamp. Is not coming on. I think it's the switch. And I have a feeling it will work its way with the use of the switch. Auxiliary is dim. It's all working now except for some of these lamps, and that's a function of the switch has been damaged in a previous life, and I don't know if there's any fixing it, but it is working now. So let's focus on something else. Alright, now the last thing I want to do is work on the tuner. The FM tuner in this thing was working pretty poor. Let's try this out. On auxiliary, let's go to AM. Seems the AM's not even working. It's picking up stations, but wicked interference here. Okay, AM is working terrible, so let's try FM. FM auto. It's got this auto muting thing. I don't know if you can see this, but the meter is way off to one side, which tells me the discriminator or the ratio detector is out of tune. No FM stereo. I just think that it needs an alignment on both sides of the tuner. And it sounds flat. It sounds terrible.
% interest or discounts up to $16,000 off.
So what I'm going to do is I'm going to go through an AM/FM alignment. I'm going to see if that improves anything or it discovers any problems, and I'll bring you back in and let you know how it goes. I'm not going to film the process. I'm just going to go through and do it, and we'll do alignment of the dial scale, all that. We'll go through everything, and we'll make sure that this is done correctly. See if we can bring this FM tuner back to sounding good again. Even the AM doesn't sound like it's working properly. Let's try that again. Like it's picking up signals and they're coming in strong. All this background interference is just horrible. And I do have my lights turned off. Usually gets worse when I turn them on. Okay. Enough of me yakking, let's get to work. Okay, I think I got this dialed in. Yeah, there was quite a bit of stuff that was out of adjustment. Not so much the dial scale. The dial scale was pretty accurate, and the tuning block was accurate. It was dialed in, but the tuner itself, the tuner IF and whatever, I had to go through and do some adjustments. Got my stereo back, got our sensitivity back, got the tuning needle is centered now when you hit the station. That was way off one side. So let's go through the band.
Or Dr. Greg Zobel for wisdom tooth extractions. We offer sedation options.
and it's pretty sensitive now. They're all coming in stereo.
Persisted in a big way until last year, and then after going through that
That's a weak station.
program,
I don't have any stereo there.
It really is.
That was pretty weak.
Okay.
They're all coming in pretty good now. Here's a strong one.
I heard that too. I know
Not a bad news. 1049 Virgin Radio.
From Hope and Healing International.
Yeah, so I'm pleased with the FM tuner now. It's working better, much better than when it came in. And the AM, I didn't touch the AM yet, but let's give it another short test. It's still swamped with noise. It's not picking anything up now. I wonder if I have a problem with it. I'm going to look into this AM. Okay, AM's dialed in. Just need a little bit of a band accuracy adjustment just to get it back into place. Turn off the signal generator. Yeah, so this is all done. I'm glad the tuner dialed in, and now I can get this finished for the client, get it wrapped up. Well, there it is, all finished. I'm pleased with the outcome of this one. I gave the cabinet a good clean. The wood was filthy, came out pretty dirty, the rag I was using. Cleaned it, and I gave it a treatment of Danish oil. That made a lot of the scratches and little blemishes disappear. And it looks a lot better now. I don't know if you can see it. It's got a little gloss to it now. Until it dries, it has a little gloss. Not overly objectionable. I like it. So I'm going to enjoy listening to this for the next few weeks. It was a treat to work on too. Except it had some unique problems. Whoever sprayed these switches with that, I don't know, they used some kind of spray grease that actually damaged the switch and burned out the contacts because it was making a poor connection and high resistance, and burned out. So that kind of ruined the lighting for this. So I had to go in and repair this switch and add a relay to get these lamps to work again. And it's nice. It's a nice unit. Everything else, capacitors were all in good shape, but they all got replaced regardless of the condition because of age. These are old Elna caps, and they hold up really well. I've seen these 50-year-old caps hold up like brand new. But still, a lot of these orange caps in here, their values are all over the place, so it's nice to get fresh caps in and get all those values to match in each channel. That way you have a better match of sound. Quite a few resistors I replaced in the tuner. These carbon comp resistors, I took out probably 10. And then I replaced a number of known bad transistors. Not very many. I think there were 6 altogether. So not too many parts went into this, and it didn't really need that much help. It was working pretty good when I got it, except for, you know, dirty switches. The lamps were out, and everything. So it was otherwise okay. So I'm going to wrap this up, and thanks for watching. Got lots of stuff coming up, so stay tuned, and we'll see you on the next one. Thanks.